This is probably motherboard number 5 that we've done about the X570 chipset, and actually the 6th video, because the way a chipset's been designed for a motherboard is different than the way the motherboard is designed, the implementation. And it's in that difference that we get those variances. And I got to tell you, I appreciate this, guys, because, you know, no matter how much you know, you never know it all. And I learn something new every time we look at one of these motherboards. And I absolutely find it fascinating on the resource allocation, how everything goes together. So as we look at this for the what, why, and how, we have to identify the problem and the solution, which will become apparent once we read the comment, which I'm getting to. And then I'll give you the title of the video based on the motherboard we're looking at. Now this question is about the Supermicro dual M.2 NVMe adapter. And I'll scroll down, I've zoomed in, and this is from Franklin Gomez. Hi, I have an Aorus Elite X570 motherboard, which has one PCI-Express by 16 and one PCI-Express by 4 slot. The by 16 is populated by my GPU, so I put this expansion card on the PCI-Express by 4 slot, but it's only picking up one of my 2 drives on the Supermicro dual M.2 NVMe adapter. Am I not able to do anything even if I run them at less bandwidth? Question. Sorry, I'm kind of new at this stuff. So our comment. Hi Franklin, welcome. Glad to help. Give me a couple of days, we'll have a video response to explain your situation, identifying the problem and the possible solution, of which I expect we're going to have possibly 4 solutions for these options, because things are not always as cut and dried and simple as they seem, and this time I want to go a little bit deeper. Not a deep dive in the weeds, but just a little bit deeper about the depth and breadth of what we've got going on. And Franklin responded, no worries, I appreciate the help, you're killing it on YouTube lately. Thank you, Franklin, I appreciate that. Our goal is we're here to help. We're all learning, and we all learn together, and by the time we get this thing figured out, around it goes, and off we go again for another one. So the biggest part of what you're asking, I want to go a little further with this, because I think there's a lot involved, and I wish I had been doing these kind of videos back when we first started this kind of stuff. But since you're asking specifically about a dual M.2 NVMe adapter, I think it's prudent that we take a look at that adapter, because it's important to know what the requirements are. And I'm going to leave this in a bag because I don't want to put the gloves on right now. I think this will be adequate. But we have a dual M.2 NVMe adapter, if I can do this without the reflection, from Supermicro. And if you'll notice, that PCI connector, any takers on what that requires? Anybody want to take a shot at it? That's not a 4-lane slot. That's an 8-lane slot. And since that requires an 8-lane slot, the problem and the solution, we're going to take a look at the motherboard. Most of you know what's obvious, but beyond the obvious, we've got to go a little bit further, because it's always about coulda, shoulda, woulda, why and why not, about the what if. And even though this will turn out to be that, I still say we've got 4 options. So let's look at the motherboard, we'll look at the chipset, and of course the CPU, and we're going to go through the PCI-Express lane allocations. So let's start with the motherboard, which is what the video is about, the Gigabyte x570 Aorus Elite. We need to go to support. We're looking for a manual or manuals, of which there could be anywhere from probably 1 to 5. One manual about the motherboard, another about the BIOS. In this situation, they're combined. Sometimes there's a quick start guide. Sometimes there's something about RAID. And with this one, yeah, we get a RAID setup, unique features, audio setup. All we need is the primary manual, 14 megs. Now, in the manual, 3 pieces of primary information I'm always looking for. One, I want a diagram. Seldom do we get it. Sometimes. We can look at the chipset. It's generic, but because, as I said in the beginning, there's so many differences and so many variances about here's the way it's designed, but here's the way it's implemented. The implementation is just all over the map. So we're going to take a look at an image that will show us that layout. But on the motherboard manual, without that diagram, some of what we're looking for is kind of hit or miss. We have to figure it out, and we can get so far, but to get the rest of the way is really in the weeds. But suffice to say, number 1, I want a diagram. Number 2, I want to see the motherboard layout. That's the first place we really get started. Then we need to look at the specifications, and then after the specifications, we're going to be looking for something about how that stuff is laid out, which could be number 4, and number 5 might be what's in the BIOS if we get that far based on the resource allocations. So to the manual we go. Looking for specifications, gets us to the table of contents. So we notice we've got a motherboard layout, product specifications, and we've got connectors. So what I'll be looking for in the BIOS, if we get that far, could be number 1, bifurcation, number 2, 4x4x4x4, which means the same thing. We're on a Gigabyte board since we're not on ASUS, so the terminology will be different. ASUS calls it one thing, which is kind of a misnomer. Gigabyte is a little more straightforward about the technology. The other thing I'd be looking for would be possibly shared bandwidth, and then of course down to it we're looking at the PCI-Express by 16 slot, and then we'll be looking at resources on the M.2 connectors. Now I usually stop with those two. I usually don't go further. Today I want to go a little further because I want to explain how all this stuff works, how it sets out, knowing what the requirements are for a card like this, because there's a way to do this even on this motherboard, even if it's not necessarily with this card. The two requirements we're facing, number 1, we need a by 8 slot, so keep that in mind. Number 2, we need to be able to bifurcate that slot in the BIOS. So those two things, keep that in mind. Now that's specific to this card, the Supermicro dual M.2 NVMe adapter. However, for those of you that already know, hold that thought. For those of you that don't understand, we don't have enough resources. I'm going to show you and lay all that out. But there is a way to do what this card can do on another card as one of our options that I want to get to, that is kind of amazing when you think about it. But it's always about, how do we make it work, keep it simple, what's the problem, and how do we solve this? And we're going to have 4 options. But I really want to go through this stuff about the BIOS and about the motherboard layout. So let's go to page number 5. Let's see our layout. And the first thing we've got, wow, okay, we've got 2 slots, PCI-Express by 16 and PCI-Express by 4. I appreciate that, because if you notice, those are both by 16 mechanically, but electrically by 16 and by 4. So 16 lanes and 4 lanes. Okay, the primary slot to the CPU by 16, we have a primary M.2 NVMe connector. That's 4 lanes, so that gives us 16 plus 4, 20. Then through the chipset, and we'll go through and itemize all this. Number 1, we've got PCI-Express by 4 lanes, and then we have M.2 B NVMe drive, also through the chipset, 4 lanes, and then a PCI-Express by 1, underscore 1, and PCI-Express by 1, underscore 2. Each of those are by 1 single slot and a single lane. So that gives us 4, 8, 9, 10. So far we've got 20 on top by that count, and 10 on the bottom by that count. Let's go now back to the top, specifications, and that table of contents on page 4. So we're looking at page 4, page 5, product specifications on page 7, and we're going to determine what's what based on, and you did not tell me about the processor, but let's just keep this simple, and suffice to say I hope you're using a 5950. So if we're using a Ryzen 3rd generation 5950, we get the full benefit of everything. Okay, dual channel. So with 4 memory slots, I would probably stick with DDR4 3200, but check based on price and see what you've got. And I would only use 2 sticks. Stick with Windows 10 until that TPM issue is solved. And if you're using Windows 11 based on the TPM, then I would get a real TPM, not the virtual, until that's all sorted out. So else you'll have that stuttering. Let's look at, we'll go to page 8. Okay, expansion slots integrated in the CPU, PCI-Express by 16. PCI-Express by 16 running at PCI-Express 4.0, so that's 16 lanes. Integrated in the chipset, PCI-Express by 4 and PCI-Express by 1. All of those slots are through the chipset. And let's look at the M.2 connectors. Our storage, M.2A underscore socket, and then M.2B underscore socket. Okay, M.2A to the CPU, 4 PCI-Express lanes, and through the chipset, M.2B, 1 M.2 connector, 4 PCI-Express lanes. And then there are 6 SATA ports. Each one of those SATA ports, those also require 1 lane, so there's 6 lanes. So right off the bat, you can see you have a 16-lane slot to the CPU, you have a 4-lane slot through the chipset. You need an 8-lane slot for this that you don't have, so that ain't going to work. So what I want to do is go through and look at, and I'm going to show you an image that I found this, I think, at WCCF Tech. I'll have a link up to it. This image is actually from a slide from a presentation from AMD, and I'm using this particular one because I can blow it up full screen without it getting pixelated. Everybody else had an image that would pixelate. It will show us generically how the chipset is laid out, so you can see how lane assignments. It's a little bit confusing, so I'll show you what I know, and let's talk about it, because there's still 4 solutions for this. Even if you can't use this card, there's another way to do what you're trying to do. It depends on what you're trying to do and why you're trying to do it. In other words, if this is for video, I've got 4 solutions. If this is for audio, I've got 1 solution. If this is for anything else, we need to talk. And if you're looking at direct storage, which is Windows 11, remember that physical TPM. So let's take a look. First of all, at your processor. And the processor and the chipset, this goes back to 2020, actually 2019, some of the stuff I'm going to show you. But this is about the number of lanes. You know, it's always a question of how you count the lanes. So this is talking about 24 lanes. So remember that. I'll have this link in the description. And this is on Guru 3D. They had a nice image. Their image I'm not going to show you because it'll pixelate. And from Hexus, this may be the one I was thinking of that was on WCCF Tech. Yeah, this is the one from Hexus. Okay, this is about 2019, about the Ryzen 3000. We're looking at a Ryzen 5000. So what we're looking at will be relevant to the chipset and for the processor. So I'm going to pull this image out and blow that up full screen. And you can see here what we're looking at. Okay, AMD X570, the most modern I/O. Right up here at the top left, I'll zoom in on that so we can see a little bit better. 4 super speed USB 3 10 gigabit ports. So if that's 4 USB 10 gigabit ports, and for reference, let's look at the manual again. We are looking at right here, USB integrated into the CPU, 4 USB 3.2 generation 1 ports. Okay, even though they're said to be 10 gigabit ports, you have to allow for marketing, you have to allow for bandwidth, you have to allow for that overhead. So those, suffice to say, 10 gigabit ports, if you were to, because of USB 3, plug something into them for network access, and you'll get where I'm going when I get there, they would be like a 6 gigabit port, which is actually 5 gigabit because nobody makes a 6 gigabit USB 3 to Ethernet adapter. So if I have 4 PCI-Express lanes, and I have those 4 ports, it would behoove us, instead of using those 4 PCI-Express lanes, give us 4 USB 3 ports to have 1 RJ45 for a 10 gigabit Ethernet. I'm going to say that, and I'm going to show you how that's wired. From the table of contents, I want to go to the back panel connectors, which are on page 13 and right here. Now for back panel connectors, my point is, those 4 right there, those are the ones that are to the CPU. These 4, and then these 2, and then of course there's a network. Here's your audio, and then there's the HDMI, if you had a processor that could use it. Okay, let's go back to the table of contents, and of course the internal connectors. We're looking at the M.2 _1, M.2 _2, or M.2a and M.2b in this case, and back to the motherboard layout, because that's really the best information we have. Because we are limited on our resources, our PCI-Express resources, based on the way they are implemented on this motherboard, we cannot use the Supermicro dual M.2 NVMe adapter. Now, because this requires 8 lanes, of which we only have 4, and we have 2 M.2 NVMe drives, which requires 4 lanes for each one of these drives, hence a total of 8 lanes, then what we need to look at for an option would be a different card that would allow 2 drives to be utilized in a 4-lane slot. Such does exist. If you know about it, but if you don't, and there's actually one company that makes 2 different cards. I don't know what the price of the card is. I'll have the link in the description. I'm going to show you. It's from Amphitech that makes the Squid, the 6-drive card out of Canada. Phenomenal technology because they have an edge connector in their parts list that can be changed. If you, in other words, order the optional part, you can go from a 8-lane slot, which is in the box, add the part to change out the edge connector to a 4-lane slot, which is pretty wild. And we tried it both ways with the Amphitech Squid. It works. It's phenomenal. We had 6 drives on an 8-lane slot. Pretty wicked, because it has bifurcation built on board. This requires motherboard bifurcation with the Supermicro. With the Amphitech cards, they are self-bifurcated. They have a PLX chip on board, which is why they're so expensive to do the lane switching. I want to show you something with the chipset right quick so you understand, so that as you go through this path down the road later, you'll have a better understanding. When you're looking at a motherboard, what are you looking at? What do you choose a motherboard for? And my thing is, and I hope you don't tell me you bought it because you thought it was pretty, and I hope you didn't buy it strictly based on price. We're always about value, building a purpose-built machine. If I'm going to use this to do audio with, again, this solution from Amphitech I still think will work. But there are some other options, because you have a 4-lane slot. I'll tell you right now, you could put an RJ45. In other words, you could put a 10 gigabit Ethernet card in that 4-lane slot. Now, ideally, if you use something with an Intel chipset, it's going to take an 8-lane slot. But Asus has a card, and Trend Micro has a card. I'll have a link up to the Trend Micro because it's still available. That based on this machine for what it does, you could put an RJ45 in there. Now, if you're doing this with audio, because we didn't get into that, the Amphitech. But I want to take a look at the chipset and try to explain some of these resource allocations, so it'll hopefully make a little more sense. And depending on how you count, you're going to get different numbers. But like I said, to reiterate, I always stop when I get to the things that are most important, which is number 1, the PCI-Express slot, number 2, the M.2 drives, because that's what really matters. But if you want to count it all, let's read this. Starting with AMD on the 5950, at the specifications, we're talking 16 cores, 32 threads. In one breath, I don't understand why the vendors don't show these numbers that we're talking about. But in another breath, I do understand, because this is what I call obfuscation. They don't want to. It's like, don't look at that over there. Look over here at this. Look how pretty this motherboard is. Okay, a 5950 has 16 cores, 32 threads. That's great. How many PCI-Express lanes do we have? Because that's all about PCI-Express lanes. That's the reason we look at cards like this, because what's this made for? The Supermicro is made for a server, a workstation, a high-end desktop. Anything below that, which is what we're looking at, to do this, Asus has done the most to enable these kinds of technologies. Now, we've talked extensively about the quad cards. We've talked a little bit about the dual adapter. The Supermicro is my favorite. But again, it's got to have a bifurcated slot. It's got to have some technology that we're not even trying to look at on the motherboard for the BIOS to do that, because the way the lanes are allocated on this board, they're not there. So how do we get to make this work? Let's look at the diagram that I talked to earlier about the chipset. And again, to reiterate, this is from Hexus. AMD x570. Now we're looking at the CPU right here. And there's 4 lanes that tie the chipset to the CPU. So what we're looking at, 20 PCI-Express lanes, 16 lanes for the GPU, 4 lanes for the chipset downlink. They call that 20 lanes, okay? Then you pick another down here. We've got one M.2 NVMe drive to the CPU. That gives us 24 lanes. So you can either count 24 or you can count 28, because these 4 USB 10 gigabit ports are each occupying a lane. That's 4 lanes. And I would rather have those 4 lanes, but it is what it is. Now, in one breath, we can say, well, that's to the CPU, yes. And I have not seen a motherboard configured with those 4 lanes to an RJ45. However, if you take into account on a higher end processor that does have the lanes, you could put, even though 10 gigabit is built on the motherboard, you could put a card in a PCI slot that's to the CPU that would work on 10 gigabit. So it's doable, but it hasn't been done. Why, I don't know, but I pointed out. Anyway, you count 20 lanes, you count 24, or you count 28, however you count the lanes. What matters is the lanes that we can allocate. The GPU, which is 16 lanes, if you had 2 slots to the CPU, you would have 8 and 8. So then we'd be trying to figure out how to divvy that up, to use one and not use the other one like it didn't exist like you have right now. So you have 16 lanes. So 16 lanes to the GPU, and then 4 lanes to the primary M.2 connector. There's 20 lanes. So 20 lanes that can be allocated. The other lanes, however you want to count them, that cannot be reallocated. They are what they are. But to remember how they're allocated is good for reference that I don't get into. Okay, how many lanes do we have in the chipset? According to AMD, we can take a look at X570 motherboards and preferably the specifications. And suffice to say, AMD says we have 36 usable PCI-Express 4.0 lanes. If you want to do the math and run through the count, figure that out. Most everyone will say there's actually 16 lanes. I did a count on the other lanes, and I've never been able to get all 36 lanes figured out. That is the reason for the diagram that we don't have. Without it, it's kind of a guess. Again, you can do the math and run through it because I think it's curious. But what matters is how we get to 16 lanes out of those 36 that can be configured. And that math is easy. Looking at the motherboard, 4 lanes for an M.2, and this is through the chipset. 4 lanes for PCI-Express by 4, so that's 8. Then PCI-Express by 1 underscore 1 and PCI-Express by 1 underscore 2. So there's 4, 8, 9, 10. Out of those 10, we have right over here on the right side 2, 4, and 6. That is 6 SATA ports. So there's our 16 lanes. So that's how that lays out. Now, 10 years ago, what was the first thing we looked at on the motherboard? We wanted, anybody? Any takers? We wanted SATA ports. So we had either 4, 6, or 8 SATA ports. And how did we get to 8 SATA ports? 2 of those SATA ports were through another chipset. And then at the end of PCI-Express 2, before we had full PCI-Express 3 functionality, when PCI-Express 3 brought us the M.2 NVMe, they took 2 of our SATA ports away. We were kind of miffed about that. That's when we started figuring out what's up with these PCI-Express lanes. Well, what we had on the new motherboards that had about a 6-month shelf life, those 2 SATA ports that they took away from us allocated to an M.2 NVMe drive, so you could have a 4-lane M.2 NVMe drive that could only use 2 lanes. So instead of it running at a potential of, say, 3,000, 3,500 megabytes, it ran at half speed, around 1750, which was faster than an SSD at 600 megabytes per second. But at the time, based on the price, I think it was about 5 times the price. It didn't justify doing that. So on PCI-Express 2, when we had the M.2 connector on those motherboards, which was a 2nd generation board, we used an M.2 SSD versus an M.2 NVMe for that reason. It was the best bang for the buck. But then when we went full-blown PCI-Express 3, where we had all 4 lanes, we made the jump, we made the leap, and we went for M.2 NVMe. And anybody that wants to know, is it worth it for an M.2 NVMe? Once you've done it, you'll never go back. And it's not about one, but it's about how many can I get in the machine. Let's take a look at Amphitech now at a possible solution. Now, for anybody asking, how did I find out about Amphitech? One of you guys told me about Amphitech. The first time someone said, what do you think of Amphitech? I said, what is an Amphitech? And when they told me about the board, I said, I have no idea, never heard of it. Let me figure it out. I did. We've done a couple of videos, which had some really good response. And then from that, I was like, wow, this is pretty cool technology. It's expensive, though. For what this costs, we can buy a workstation motherboard. I'll leave it at that. Let me show you the link. But it's an option. If you have a motherboard and you have a need, they fill it. Right up here on the top left, M.2 carrier boards. And I'll have a link into these. Right down here, there are 2. Right here, PCI-Express Generation 3 carrier board for 2 M.2 NVMe, or PCI-Express 3 carrier board for 2 M.2 SSD modules. And when you drill into both of these, I cannot tell really what the difference is. They both take M.2 NVMe drives, and they are both right here in the specifications by 4. I had someone take issue with me about the NGSFF, and I said, look, we've been very specific about M.2 NVMe PCI-Express drives, and that's what these support, and that's what we stick with. So wherever you're at, if that's a spec you deal with, that's not a spec we deal with. So I hope that clarification helps. The person that took me to task, once I reiterated what I had stated, he said, oh, right here, by 4 PCI-Express 3.0, and it'll take 2 of them. And it'll work in a by 8 or a by 4 slot, because if you scroll down here and look at the parts, there's a drive on each side. And remember, they've got a sticky that they put on these cards. Whatever's on that heatsink, that stuff sticks. I mean, really sticks. So if you're going to do this as a temporary installation, be prepared to work it off. You can't pull it off. You gotta twist it off, and you got to be really careful, because it is difficult. Another nice thing about these 2 cards, they are both half height. They come with the bracket for half height, so they'll work in a 4-unit rack mount. Right down here is the part I want to show you. Shows the standard package includes, but right here, option. This option for this connector, by 4. To reiterate, it comes with the by 8 connector. You change that connector to by 4, and the pathway, there it is. Phenomenal. Extra part, costs a little extra money. You just got to be sure and tell them about the SKU. And I still have issue with that Silicon Labs bridge driver. Just because you can install the driver does not give you access to the chipset without an application. They need to develop the application, especially for what that thing costs. My gosh almighty. But anyway, to reiterate, that's option number 1. Okay, now, option number 2, if we put that network card in that slot, because if you're doing this for video, I got something I'm going to show you that's just been announced. It's going to blow a lot of things away. It's going to change everybody's perspective and perception on RAID. It's going to change a lot of people's perception about video editing, and it deals with the Blackmagic DaVinci Resolve 18. That is going to blow people away. So let's start with the network interface. I'll have a link to this. This uses a by 4 slot, and this particular card is from TrendNet. Once that feature is enabled, then it gives you access to the other options, and all of these are from Blackmagic. I'll have a link up. Blackmagic announces the Blackmagic Cloud Store. That little box right there, which is a modification of their eGPU, which only worked on Intel Macs, is going to be available for a PC or a Mac about a month out, and that device is going to radically change how we look at network storage. So if you're interested in storage area network or network storage, that thing will come pre-configured. There's going to be 3 different models, but this is the primary model, of which there will be 3 of, at I believe 20 terabytes, 80 terabytes, and 320 terabytes. Price to be determined based on its built on an as-needed basis. So at 20 terabytes, around 10,000. 80 terabytes, quite a bit more. The other models that are below that, directly below that, is a model for around 3,000. I'll show you the link. And hopefully we might get a chance to take a look at something like that. Option number 2, which I believe this one's around 3,000, is the Blackmagic Cloud Store Mini. And looking at the unit, I believe that'll fit in a rack mount half shelf. And on the back end, you can see here we've got power. 110 volt power. There's also a 12 volt DC power, 10 gigabit Ethernet, 1 gigabit Ethernet, Ethernet via USB, and monitor out. Oh, and almost forgot. The reason I was talking about 10 gigabit Ethernet, everything with setting up with Blackmagic equipment is all about networking, and everything's worked with gigabit Ethernet when you set up the video switch. Setting up this device, I'll go back. Setting up this device as well as the primary device, this is all about 10 gigabit Ethernet. That has a 4-port 10 gigabit Ethernet switch built into the device, which means you can have 4 computers hooked up to that all at one time, or you put it on a network with a separate switch, and you can have a whole classroom full of computers, or you can have different people around the world who have access to that content all at the same time. Proxies, creates them for you on the fly. It is phenomenal. If you haven't seen it, watch the video. If you ask, I'll get a link up to it. But suffice to say, that's going to change the way network attached storage is done if your primary joy and your primary need is video. So for content creators, that thing is going to be wicked. Should be out in about a month. They claim they're beta testing it right now. It's going to obsolete a lot of RAID stuff that we've been waiting on, because this uses M.2 NVMe drives, RAID 5, and it's spec'd at 20 terabytes. It has 20 terabytes, which means there's more than 20 terabytes there because they've allowed for the overhead. But it's all M.2 NVMe drives. And it can be serviced, they said, by a technician. Well, we are our own best technicians. I would love to get my hands on one and take a look at it and see how it's all put together. But it's got to be a system on a chip. It's got its own operating system. I believe, if I remember correctly, they said it's running the Blackmagic operating system. But as an option, because I mentioned 4, I mentioned the first one, and this is the other 3, of which I got one more to show you, which would be the Blackmagic Cloud Pod, and that'll turn any USB drive into network storage. Features high-speed 10 gigabit Ethernet, and that's what it looks like. And if you'll notice the kind of drive, one of those little SanDisk drives that's plugged into it, phenomenal. So even though this video is about the Gigabyte x570 Aorus Elite motherboard and how we get a Supermicro dual M.2 NVMe adapter on that motherboard, which we can't because of the resources. To reiterate, we need 8 lanes. We don't have 8 lanes. We only got 4. And those 4 lanes in that PCI-Express by4 slot only lets you see one drive. If I went a step further and I did a PCIe by 4, I'm looking at what kind of control I have, and I did a search for PCIe by 4. That took me to the page with I/O ports to go from integrated graphics if you were using that CPU. So I have initial display out from IGD integrated display, PCI-Express 1 or PCI-Express 2, which would be PCI-Express by 4. And that gets me down to PCI-Express by 16 bifurcation. There's no way to bifurcate the by 4 slot because in this particular motherboard, the by 1 slots don't share bandwidth with the by 4 slot, which is good. We looked at another motherboard that did, which was kind of wonky. But, you know, every motherboard is different. That's what I get a kick out of looking at every one of these, seeing how this is working, because it's always the what, why, and how. How do we make it work? And if we can't make it work, what can we do to get to what you're trying to achieve? So again, to reiterate, the only slot we can bifurcate is the by 16. But since the GPU is there, it's going to stay there. But I'm just saying. The options are auto, PCI-Express 2x8, which is useless, PCI-Express 1x8 and 2x4, again, which is useless, or PCI-Express 4x4. If that 4x4 is a full 4x4x4x4, then theoretically you could put a quad card in there. Or if you did a dual adapter, but that would be poor use of resources just for this, when the Amphitech card can do what you want, but it's going to cost you more than the motherboard. Like I said, those are like buying a workstation motherboard. Well, if you're going to buy a workstation motherboard, then just build a workstation. But we're working with what you got, and that's where we're at. So I hope next time, please get in touch with us. Let's talk chipsets. Chipsets rule. Your motherboard is the foundation of the computer, but the chipset is the foundation of the motherboard. Chipsets rule. So as we look at what you try to do with a Supermicro card, that's why I wanted to make this video, because I wanted to share this information with those 4 options. So my name is Gil Boyd. This is BuildOrBuy. I want to thank you for watching. We look forward to seeing you next video. We're out.